So the design process is continually shrinking, trying to get it shorter and shorter time cycles. And part of that process is analysis. Analysis has typically been at the end of the design cycle for validation. And I think there's been pressure to move that earlier and earlier and earlier in the design process so that we can more quickly give directional feedback to engineers. So some of the claims piqued our interest. You can do it designing a lot faster, analysis a lot faster in that software. So SimSolid gives us the ability to push that analysis earlier on in the design phase, early and on enough to be able to refine our design so that when we do go to make a prototype, we have a much better shot at that passing and not having to have major problems with it.
Sure, I think like a lot of engineers, we're used to seeing claims that something is X% better or so much faster. That was certainly one of the big claims, is that it's going to be many, many times faster to create a model and solve many times quicker. And that was a bit of a paradigm shift from what we're used to in the FE world, where there are more incremental gains that we expect to see, but it's a fundamentally different tool solving the problem in a different way. It was surprising how easy it was to get to use. With very little guidance, we had an engineer work through a very real problem quite quickly, and we saw a massive improvement in terms of the speed to generate the results, and the quality was and accuracy was within the realm of what we expected, given how much faster we were able to get to that answer.
So SimSolid is really a breakthrough for us, because the time we spend in CAD preparation, in meshing, it's an activity that has no added value, by the way. So by using SimSolid, we reduce drastically the time we spend on doing simulation. SimSolid is very good for that because it's very fast, no preparation, no meshing, so the risk of failure is very low.